Hey YouTube! So today I'm going to do a little bit of a different style video. I'm on my computer at home, and instead of doing the hardware that I've been showing you guys recently for our project, I'm going to be showing you some of the software that we're doing. So what we have been working on over the weekend as well as today is we have a NEMA 17 stepper motor, and it's connected to a lead screw. So I did draw a map, but I think it might be a little bit easier if we just go through everything together. If you just want to see the map, this is what we saw. The handwriting is extremely bad, but so we go from Arduino or MATLAB. In this case, we decided that Arduino is probably going to be the best way to go. And then we have to do some things with the stepper motors, and then that'll be able to send it back to MATLAB, and then we could create a 3D volume. So we have the NEMA 17 that's connected to a lead screw. So this stepper motor is really what we have been working on for the past couple days. And I finally got some code working, so I'm going to be sharing that with you today. So this NEMA 17, what we wanted it to do is we want it to have a 0, 0 or a home position. Since it's only one direction, so we have it on a lead screw like this, and then we have the NEMA 17, which is going to be rotating it. The second axis doesn't matter because that's going to be a second NEMA 17 stepper motor. So really all we're going to do is we're going to have some value here that's our home position. And we want to be able to return to the home position no matter where we are along this line. So it is a little bit more difficult to perform than it is to just say. So obviously we're not going to be able to store values, so this is only going to work one time, so per use pretty much. And so we're going to have the stepper motor that starts off at this home position. It'll be able to travel X distance. And then as it travels this X distance, it's going to change a value, which we call distance, in the Arduino IDE. And then once it subtracts, it's going to keep subtracting values until it gets all the way back either to 0 or we stop telling it to go in that direction. And then what I did is for the NEMA 17, there's a stepper motor driver that has a pin called enable. That enable pin, all I did is I hooked it up to a button, and then that'll determine which direction. So the enable pin of the ESP32, the microcontroller we're using, is going to determine the direction. So I hooked that up. So no matter what, this is always going to be hot. This is always going to have a 3.3 volt, 3.3 volt output, and then this button is going to be what determines whether that output gets sent or not. And so that output is going to go directly to this distance. When the button is pushed, it's going to go back. Oh, I'm sorry. When the button is when the button is pushed, it's going to go forwards. If nothing is pushed, it's going to stand still. And then if the button is released and it's not at the home position, it's going to start going back to the home position. So to draw this out a little bit better, we have, here's our lead screw, here's our stepper motor. It's just connected like this. There's like a hole, and then the stepper motor goes in here and it rotates. And then we have a block that's on the lead screw. This is going to be what's connecting the ultrasound probe. And then we'll have like the ultrasound probe going down here. This is going into the page. So this will be rotating and it'll end up going all the way down here. This is the home position. As I'm pressing the button, it's going to be subtracting values, so it's going to be going down this way. When I release the button, it's going to go all the way back down to the home. So once we go to the Arduino code here, this is going to be what we did. We included the stepper motor library. We initialized a max value at 100, which I don't think we're actually going to end up using. But before I actually started making everything, I was like, oh, how do I do this? Started asking ChatGPT a couple questions, but that's why you see like some of these comments. but ChatGPT was really bad. It kept giving me code that just didn't work. So you could see the comments just like stop in the void loop because it wasn't working at all. So we initialize everything in here. This is just setting up some of the pins we're using. This is going to change based on whatever you're using. And then this is just for our NEMA 17 stepper motor. This is going to be 0.11. Not really 100% sure what this does. Our teammate Ani, he was the one who came up with all of this, except these values here. Okay, and then so the pin mode, we're just determining what the ESP32 is going to be doing with the pins. Technically it's the Arduino IDE, but we're using ESP32. It's kind of like Samsung and Apple. It's pretty much the same thing. So just setting up some of the outputs. So the direction pins and output, the step pins and output. Step pin is what I was calling enable earlier. So that was a mistake on my bad. And then this button pin is an input. That's what's going to be telling us when I'm pressing the button. I didn't do any anti-bounce or debouncing for this just because it's not really important since we're not going to be sticking with a button the entire time. So here we're going to write the pin is always going to be high. So no matter what, it's outside of a loop, or it's in this void loop, but it's outside of these whiles. So no matter what, it's always going to be high. We're going to have this distance, which is arbitrary right now, but once we have the actual length of the phantom that we're imaging, we're going to be able to use these 350 microseconds, the, where did it go? 16 microsteps. And then we'll be able to figure out how fast our stepper motor is going, and then we can end up making a video that's exactly as long as we want based on this distance. So in our case, we want it to be about 10 seconds, but I'll show you the math once we get there. We haven't started that yet. So this is going to be, we're going to read the button, or the button pin. So I'm going to push a button, it'll change this value since it's input, and it needs to be low. So when it's low, I'm not holding the button, and the distance needs to be less than 100. So this just means we're at some point anywhere over here. I mean, it could also be here, but just not at the home position, and I'm not pressing the button. So then this will happen, and what it's doing is it's just going to start stepping, but it's going to step in reverse. And then here we're just going to print the distance every time that it's done stepping. So I don't have it plugged in right now. I don't have it with me at home. It's in our lab at school. So then here we have the button pin. It's going to be high, and then this is only when the distance is greater than 0, and it'll start bringing the distance back to the home position. Oh, I'm sorry. That was this one. This one is going to start bringing it away from the home position until a value of 0. Now, obviously, the way it's set up right now, I think we get to like negative 0.001 or something. So it's not ideal right now. We're going to end up doing the math later. But so this is how we're going to be doing the stepper motor. The stepper motor then can communicate to MATLAB to say how long the video was, but we're not really quite there yet. I'll show you guys that later. One thing that I did want to show you was our MATLAB. So this is the MATLAB GUI that I made. Over here you could change the intensity of the image. So just a little bit of a background of what this image is. It's a 10-second sweep of an ultrasound phantom that has 4 rods. You could kind of see them. There's one, I don't know if you can see me. Yeah, you can see my mouse. There's one here, this one gets bigger, this one gets smaller, this one gets smaller, this one also gets smaller, this one gets bigger. So on the bottom here, you can change the intensity thresholding. The threshold's in the wrong spot right now, I need to fix that, but let's try and get it so that we could see one, I think around, this should be good, yeah. So you can see one full tube here. And then what you could do is you could do a cut plane. So we're gonna go ahead and cut, I don't like this, hold on. I always do this one. This one automatically draws a cut plane for you. My computer's really slow though, so I'm sorry. I gotta get a new computer. So all this is gonna do is it's gonna add a clipping plane so that we can cut this image. Here we go. If we slide it in and out, you could see we're cutting into the ultrasound image, and you can see all the data in between each point. Or if we rotate it, it's going to cut everything real quick. I'll just bring it back up. You could slide it down, and that's going to cut everything vertically. So if you're looking for lesions, that'll definitely help. But so that's the MATLAB code that we're using, and we're going to try and get the Arduino IDE code matched up with this MATLAB code so that we can do the same plane, but we're just going to be sending the data from the Arduino IDE to MATLAB, and then we also have an app that's taking all of these images. So that's the project in a nutshell. Here is the old map that we made before. Ignore Ryan's concern. Yeah, so I'll catch you guys up later. See ya.